graph and how do you represent any motion of an object on a graph? So everyone knows that we use equations of motion to represent, and what is graph? It sometimes creates confusion. So let's make it easy and understand what is a graph and how do you read it. So graphical representation is to describe the motion of an object. We use the graphs, and these graphs are drawn in line form. So let's not complicate it. The first one is a distance time graph. In a distance time graph, I will show you and I'll draw it. In a distance time graph, what is done? You show the distance. Now, I think everyone knows that whenever we make a graph, we use a vertical line and then we use a horizontal line. So whenever we use a graph, we use two lines. If you have done coordinate geometry, then this is the x and this is the y axis, and this is normally 0. Now when you make a distance time graph, on the x axis we normally show the time. So this is shown for showing the time, and the time is increasing, and this is the distance. Now distance in SI unit, both will have SI units. So in your book, the distance time graph is shown. If you see figure 8.3, the distance time graph is shown like this, and there are some numbers mentioned here. They are uniformly drawn, and they are nothing to worry and nothing to complicate. They have shown some numbers 15, 20, 30. So there is a number written here 15, then 20, then 30, and these are, so they have to be uniform. So when you have to draw a graph or you have to read a graph, you have to see that the division should be equal, and in same in the x-axis the time also should be uniformly drawn. In this graph they have shown numbers which are 20, 40 and 60. So they have shown with more gap, so 20, 40. Now the graph is shown and the number is drawn. So when you see a graph in a straight line and it is a distance time graph, so you have to remember that distance and time graph, if this graph is a straight line, it is represented as a uniform graph. So since the slope is straight, when the object travels equal distance, now in theory you have read that when the object travels equal distance in equal time, there is equal gap, 0 to 20, gap of 20, 20 to 40. It could be 10 here, it could be 30 here, there is equal gap, and here also there is equal gap of 15, 15. When the body covers equal distance in equal time, it moves with uniform speed. So this graph represents uniform speed. Why speed? Because speed is equal to distance upon time, and it is traveling a fixed distance. For uniform speed, in short we can say that the slope of the graph is a straight line, and the portion of the graph shows that the distance is increasing at a uniform rate. The distance is increasing means there is 0, 15, 30. So if I draw a dotted line here, it will come here. If I draw another dotted line, it is coming here. If I draw, this is normally drawn to a scale, but I have not drawn on a scale. Now you are seeing that here it is 15, distance is written in meter. So 15 meter in 10, and this is in seconds. Now in the book it is given in minute. Now just to understand that this is kilometer, it is not even meter, it is kilometer. So 15 kilometer in 10 minutes, 30, 15, 0, 15, 30, 45. So the distances are covering in a fixed span. In the book it is given 10, 20, 30, 40, and the gap is equal 10, 10, 10 and 10 and so on. So if the gap remains same, then it is uniform distance. Here it is uniform distance. If the slope is a straight line, it means it is a uniform speed. So uniform speed distance time graph can be used to find the speed of the body. You can calculate the speed of the body at different points, at this point or at this point. So at this point, what will be the speed of the body? If you have to find speed of the body at this point, you will see that the distance is 40, and at this time the time taken is 40. So if you will divide, it will give you the answer. And if we have to find the speed of the body at this point, we will divide the time, distance and time. But if I have to find the speed of the body, it can be represented as uniform speed is equal to the difference. So whatever is the distance covered here, so you will find that it is 40 here at this point. So it is 40, and here it is given 20. So 40 minus 20 and upon whatever is the time. So at this point, what is the time? The time is 40, and at this time the time is 20. So when I will put the number, it will give me whatever is the uniform speed. It will give a uniform speed of the body. So this is for drawing the graph. And here in the book, when you plot the distance, it is written here. According to the graph which is given in the book, the numbers are shown. Time is 0, distance is 0, time is 2, this is plotting. So you are comparing how much time is taken to cover this much distance. So this straight line shows uniform. If the line is not straight, the distance time graph for the motion of the car is shown in 8.4. The shape of this graph is different. Now this graph is not a straight line. So if the graph is not a straight line, then the distance time graph is bending. It is different. The shape of this is different from the earlier. The nature of this graph shows the non-linear variation. So it is non-uniform. The speed is different. Why is it different? Because at this time, the distance covered is, if you put the number here, and here the time is given 3. If you check the time here, it is 4. Here the distance is different. At different points which the dots are there, if you just draw a dotted line here, according to, if you have drawn the graphs in maths, you will see that the distances are not coming same. The time may come same. At this point the time is 2, here it is 4, here it is 4, and 2, 4, 6, 8, and then 10. And here the distance is coming 25, here it is coming 16 something. So the distance is not same, and the nature of the graph shows non-linear variation of the distance. The graph is showing motion with non-uniform speed. So if the graph is curved, it is non-uniform. Now same thing goes with velocity time graph. This was distance time graph, now it is velocity time graph. So when you are calling it velocity time graph, it means you are showing velocity against time. Now what is the use of this graph? Here we make velocity here and we write time here, and the graph shows starting from 40. It is not a slope, it is shown horizontal. What is the meaning of this? The velocity is 40 and it is written here kilometer per hour. So at 40 kilometer per hour, the first point is A. This is A, and here the time is given. So this is 1, 2, 3, 4. These are hours, and here it is 40. So what is the velocity? Velocity is the speed which is in the vector quantity. So if you calculate the velocity kilometer per hour, at point A the velocity is 40 and the time is whatever is the time here, it is 1 and 2 if you measure it. Then what is the velocity at next point? It is remains 40 and the time has increased. So the variation in velocity with time for an object moving in a straight line. If a body is moving in a straight line and it is not changing the direction, it is represented by a velocity time graph which remains straight. So since the velocity is not changing, it remains 40 here also, here at different points. Only the time is increasing. It is represented on the x, the velocity is represented along the y. So if the object moves at uniform velocity, the height of the velocity time graph will not change. So what is the meaning? The velocity was, if we just draw the graph, you will understand that since this graph was drawn, now let's take, it was written here 40 and the graph is drawn horizontally. So at every point the velocity is 40 only. Only at this point the time is given. At this point the time is given. So since the arrow is showing here, the time at this point is less. At this point the time is more. But at this point the velocity is 40 only, and at this point the velocity is 40. So the speed of the body, which is the velocity, is 40 only. The time has increased. So this body is moving with a uniform velocity. So I hope you have understood why it is uniform velocity. The velocity did not change, it remains 40. So now what is the meaning and what is the implication of this graph? Now you know that if you know the velocity and you also know the time, and these two are multiplied, in a way you are multiplying the speed into time. So the product of velocity and time gives displacement. So if you multiply this, it will give displacement. Now if you confuse in this, just remember the formula of speed. Speed is equal to distance, this everyone knows, and velocity is equal to displacement upon the time. So this you remember, velocity is displacement. It is displacement because it has direction and upon time. Now when you multiply velocity with time, it will give you displacement. And here what do you get? S into t. If you multiply, you will get d. And here when you will multiply v into t, it will give you d. So here it is distance, here it is displacement. Now what is the meaning of this in the graph? In the graph, if we will multiply, and here it is explained that if to know the distance moved, or the displacement of the body, we will multiply velocity. So if you know the velocity of the body at this point, you will multiply it by time. If you know the velocity here, you will multiply. And in this graph, if you read this, it is given the product of velocity and time gives displacement. The area enclosed by the velocity time graph will be equal to displacement. If you multiply this into this, if you multiply this with this, it will give you area of this. So this is like a rectangle. If you multiply this with this, it will give you, will be equal to the magnitude of displacement, because when you multiply velocity with time, it gives you displacement. So in a way, if you are given a velocity time graph, v and t graph, then the product of this into this gives you area of this. So if you find area of the rectangle, you are finding the displacement. That is the meaning of this. And the velocity time graph in your book is shown, in some readings are there. So we can also study about uniformly accelerated motion. So if you multiply, this is the calculation which is given for this graph, which is shown on this side of this. Here it is showing velocity of a car at regular intervals. Now I just read this. it is showing velocity is 0. So when the car starts from rest, time is 0. When the car moves in time 5 seconds, its velocity is 9. When the time is 10, its velocity is 18. When the time is 15, then the velocity is 27. Then if you find the velocity of the car in meter per second, so velocity of the car at regular intervals, and when you calculate the distance covered, you will multiply v into t. So in this case, at different points we can calculate the displacement, and when you calculate it, the graph which is shown for this question for the information is in the form of slope. Now what is this? This is again a velocity time graph. Previously the graph was like this. Now this velocity is 40, it remains 40, but in this the velocity at this point A is shown 20. At this point it is showing less than 40, let's say 35. So here the velocity was 30, here the velocity is more, so the velocity has changed, and the time of course also has changed, 10 and 20. So if we assume that this is the starting velocity and this is the final velocity, then initial velocity and final velocity, I am assuming that you know what is initial and final velocity. So if initial and final velocities are given and times are given, you will do according to the equation of motion, you will do u, and you are knowing v also, and you know the initial time and you know the final time. So when you will do v minus u upon the total time taken, it will give you the acceleration. So here you can see it is written velocity time graph showing uniform acceleration. You can also determine, now this graph can be calculated like this, or you can calculate, if it is a velocity time graph and it is shown like this, you can calculate this way also. So if you find area of this graph, the graph is shown like this and there is a slope shown here. So then A and B are given. So if we find area of this figure, it will give area of the figure, and the area of this figure can be calculated. It is like a, what is this shape? It is like a trapezium. So this becomes parallel side, this becomes parallel side. You can measure the length of this from 0 to this point and from 0 to this point. So you will need this distance, you will need this distance and this gap. So in the book they have given add the two and multiply. So it will give you area of the trapezium is equal to half into sum of parallel sides. According to the book, the number, let's say it is given here 10 and this is written here. Here it is written 20 velocity and here it is written 40. So if I calculate, this is velocity, this is 20, and since it is velocity it will be meter per second and here it will be seconds. So I will do 40 and 20, 20 and 10. This is the time and this is the velocity. So how much is the gap here? 10. And what is the gap here? It is 10. So how much is this and how much is this? So this is 20, this is 40. So we can do half into sum of parallel sides. So 10 plus 40 into 10. This is 10, this is 40 parallel sides and multiplied by height. So this will give me the area of the trapezium. In the book they have mentioned it in the form of rectangle and a triangle. You can do it this way also. Then this graph shows the velocity is decreasing, this shows velocity is increasing, then there is a decrease increasing. So this is a variable and it is called non-uniformly accelerated graph. So if the slope of the graph is not straight and it is going 30 and then it is becoming less, so the velocity of the body is, what else you can say, that the body initially comes to rest because the time becomes 0 and velocity becomes 0. So speed of the body is decreasing. Here the speed is increasing, then it is decreasing, then increasing and then decreasing. So the graph should not be confused, you have to just read and understand. And here it shows the equations of motion by graphical method. This is derivation. But if you have to follow the graph, then the graph explanation was this much, that if the graph is a straight line, the graph can be straight, it can be, if the graph is drawn and shown like this, if the graph is shown with like this, then it is non-uniform. If the graph is shown starting from here and goes down, that means the velocity is decreasing. If the velocity, just understand, if I assume that the graph is drawn like this, you are asked a question and the graph is drawn like this. So this is 0, here it can be 5, here it can be 10, this is velocity. So this is meter per second, here it is time, so and so 5, it could be any number. Now here you are seeing that the graph is not starting from 0, it is starting from 10. So since the velocity is 10, initially u will be 10, and here the velocity, suppose it is 40, so v is 40, and at this point the time is 0, and here the time is whatever is the time, suppose it is coming 25. So t, final t is equal to 25. So since initial time is 0, final time is 25, therefore u and v are given. So we will do v minus u upon time. This gives acceleration. So the velocity time graph can be used to calculate this. And this is used to calculate the equations of motion. So this is how you understand the graph. If you have any comment or you want to know anything, you can type below the video. If you want more explanation of on any topic in physics or in chemistry, you can type below the video, and I will arrange explanation of the topic. So there are a lot of videos which are lined up for you on science and physics and chemistry explanation. All the links are given in this description. Stay connected and goodbye, and don't forget to subscribe if you have arranged for the first time. See you.